Hello everyone, enjoying statistics and linear algebra. Now we do discuss a concept called a rank of a matrix. A rank of the matrix. Yeah, you can think of an R cross C matrix as a set of R row vectors, each are having C elements. One more possibility is you can think of it as set of C columns vectors, each are having R elements. A vector C columns in which R elements. One more possibility is R number of rows in which each are having a C elements. We can think any one of the matrix here. For that, a rank of a matrix is defined as the maximum number of linearly independent column vectors in the matrix. It is the first definition. Consider any matrix or R rows and C columns. Find out a number of linearly independent columns. So rank of that matrix equals to a number of linearly independent columns. One more definition is the maximum number of linearly independent row vectors in the matrix. It is also called as a rank of a matrix. Either you can find out a number of independent columns or a number of independent rows. That number gives the rank of a matrix. So both the definitions are equivalent. Consider for an R cross C matrix, if number of rows or of columns than number of columns, then the maximum rank of the matrix is a number of rows. Consider any matrix here, R cross C. If R is less than C, then a rank of a matrix is denoted as a row, always either equals to less than or equals to a number of rows here. One more possibility, if a number of rows are greater than or equals to number of columns, then rank of a matrix A will be less than or equals to a number of columns. So whichever is the smallest number, either it is row or a column, then rank of the matrix equals to less than or equals to the smallest number, either it is a row or it is a column. This concept is very important here. The rank of the matrix would be 0 only if the matrix had no elements. If the matrix had even one element, its maximum rank would be a 1. So rank of the matrix is 0 only if it is having no elements, and if it is having at least one elements, then the rank of the matrix would be 1. Then how to find out the matrix rank? First, we should reduce the given matrix into echelon form using echelon transformation. Finally, the given matrix should be converted into row reduced echelon form. We have discussed how to convert the given matrix into row reduced echelon form. Later, identify number of linearly independent vectors. Identify the number of linearly independent vectors, then count them, then that will be the result of a rank of a matrix. So therefore, to find the rank of a matrix, we simply transfer the matrix into a row echelon form and count the number of non-zero rows. Non-zero rows, at least one element should be there. It should not be equals to 0. That is called as a non-zero rows or columns. Consider here one example. A matrix A is given 0 1 2 1 2 1 2 7 8, and this matrix indicates reduced row echelon form of a given matrix A. That is done here with some operations, some row operations. We have converted the given matrix into reduced row matrix. Finally, we have found one matrix with a 0 values here. One matrix with a 0 values. Then what could be the rank of this matrix? Consider matrix A and its row reduced echelon form. Then because of a row echelon form has two zero non-zero rows here, we can find here row number 1 and row number 2. Can we call that as a non-zero rows? At least one element is non-zero here. 1 2 1 here in this row 0 is available, but second and third elements are non-zero. If that is the case, means you can say that row 1 and 2 are non-zero. Let us come to the row number 3. All elements are 0. That's why it is called as a zero row. Row 1 and 2 are called as a non-zero rows. Row 3 is called as a zero rows. Then count the number of non-zeros after converting the matrix A into row reduced form. So number of non-zero rows in a matrix are called as a linearly independent vectors. Linearly independent vectors. So because a row echelon form has two non-zero rows, we know that the matrix A has two independent row vectors, and we know that a rank of the matrix is 2. Already we have discussed the rank of the matrix is a number of independent vectors. Number of independent vectors are equals to number of non-zero rows in a given matrix. Alright, so you can verify that. We have said that row number 3 is dependent on row number 1 and 2. How it can be said? That's why the rank of matrix is reduced to rank of the matrix is reduced to 2. So here we can add 3 into row 1, then 2 into row 2, that gives row 3. So that row 1 and 2 can be used to express the row 3 here. That's why the row 3 is dependent on row 1 and row 2. What is the order of this matrix? It is 3 cross 3. Then what could be the value of rank of a matrix? Rank of a matrix A less than or equals to 3. Maximum value of the rank of a matrix is 3 because row and columns are one another same here. But in this case the rank of a matrix equals to 2 because one of the vector depends on another two vectors. That is done here. So all zeros, so that we can say that it is dependent. Number of non-zero rows are only 2. So as a result the rank of this matrix is a 2. Alright. What do you mean by full rank matrix? When all of the vectors in a matrix are linearly independent, the matrix is said to be a full rank. Consider the matrix. Its order is 2 cross 3. Its order is 3 cross 3. What is the maximum rank of this matrix? It would be 2. What is the maximum rank of this matrix? It can be a 3. You can say that matrix A is full matrix only if rank is 2. Similarly, you can say that the rank of the matrix B is full rank only if its rank is 3. Let us find out. Then can you say that a matrix A is a full matrix? What would be the value of rank of this matrix? I can say that it is 1 because matrix 2 can be represented row 2 can be represented using row 1. Here row 2 is nothing but 2 times the row 1. 2 into 1 2, 2 into 2 4, 2 into 3 is 6. So that the rank of the matrix A is not 2, here it is 1. So we can say that it is not a full rank matrix. Then come to a matrix B. Come to matrix B. Here all these vectors are independent each other. None of the vector is used to represent another vector. As a result, the rank of the matrix is 3. Rank of the matrix is 3. So that you can say that it has a full rank matrix. Alright, that is explained here. Consider the matrix X shown below. What is the rank? What is its rank? Options are given here: A, B, C, D, E. So identify whether here we do consider two rows. What is its order? 2 cross 4. Then what could be the maximum value of a rank of a matrix? It is 2. Maximum value of rank of the matrix of this matrix is, it is 2. Whether it's 2 or 1, let us find it out. So can we express any one of the vector using another vector here? No, it is not possible. It is not possible. They are independent each other. So if you multiply 2 into r1, it is 2 into 1 2, 2 into 2 4, 2 into 2 into 4, it is 8. But we don't find any vector which is used to represent the another vector, so that these two rows are independent each other. So the rank of a matrix equals to number of independent vectors in a given matrix. So we do find two independent vectors, two non-zero vectors, so that the rank of the matrix is 2. The correct answer for this question is option C. It is 2. All right, let us we find rank of this matrix. Options are given here. What is this order? Number of rows are 4, number of columns are 3, then maximum rank of this matrix is 3. Either it can be 3, 2, 1, not a 4. Maximum rank of this matrix is 3, or it can be 2, or it can be 1, not a 0, not more than 3, because it is having elements, so that it cannot have a rank of order 0, and it cannot have a rank of order rank of the matrix as 4 and onwards. What is the rank of this matrix? So just when I observe this matrix, can we represent a column 3 in terms of column 1 and 2? 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 4 is 7, 4 plus 5 is 9. So that we can make a column 3 as a 0 element here. We can make this as a 0 element. As a result, these two, we don't have any relations between these two. Any one of the matrix cannot be used to represent the another one. So that we can find only two independent vectors in a given matrix Y. Then what could be the rank of this matrix? It is 2. Alright, with this brief introduction, let us find out the rank of a matrix 1, 5, 3, 9 using a determinant concept. Let us find the rank of the matrix using determinant matrix. It is of order 2 cross 2. The maximum rank of a matrix is divided by a row of A. It can be maximum value equals to 2 or less than 2. It can be either 1 or 2. Let us find out using a determinant of a matrix. Consider the matrix A. Its order is 2 cross 2. A maximum value of rank is 2 or less than 2. Not a 0, not a more than 2. Then find out a determinant of this matrix. We know how to find out the determinant of this one. That is equals to 1 into 9 minus 5 into 3. That is equals to a minus 6. That is equals to a minus 6. It is not equals to 0 here. If that is the case means, rank of that matrix equals to its order, that is 2. Therefore the minor of order 2, which is not 0, then the rank of this matrix is 2. Alright, find out this matrix, find the rank of this matrix. What is the order of this matrix? It is 2 cross 2. Then maximum rank of this matrix is less than or equals to 2. So consider that matrix as a order of that matrix is 2 cross 2. Maximum rank of that matrix is either 2 or less than 2. It cannot be 0 or it cannot be more than 2. Only options are either it can be 1 or it can be 2. Find out a determinant of this. It is 0. So that rank of this matrix is it is 0, not 0. It is 0 here. The determinant of this matrix is 0, then rank of this matrix cannot be 2. It is less than 2. So that rank of this matrix is 1. Find the rank of this matrix. What is the order? 3 cross 3. Rank of this matrix is less than or equals to 3. Either it can be 3 or 2 or 1. That can be solved by finding the first determinant of order 3. It is not a second order here. It is a third order. Third order minor. Find out the determinant. That is 6 here. It is not equals to 0. If the first third order minor is non-zero, then obviously its rank will be 3. The order of a minor of order 3, which is not 0, then the rank of that matrix is 3. So let us take this as an assignment problem or find out the rank of this matrix. First find out rank of the matrix. First find out a rank of the matrix. Minor of order. Minor of order. If that is equals to 0, then it can be 2 or 1. Next find out minor of order 2. If that is also equals to 0, means it can be a 1. Try yourself. Then one more method to find out the rank of a matrix, echelon form. Echelon form and finding the rank of the matrix up to order 3 cross 4. Find the rank of the matrix A. It is given. One method is to solve using the determinant that we have seen here. The one more method is to find out the rank of the matrix using echelon form. So convert the given matrix into row reduced form. Find out the non-zero rows. That will be the rank of the matrix. That indicates number of independent vectors. It is of order minimum 3. Maximum rank of this matrix is 3 or less than equals to 3. Okay, do one operation here. R2 is equals to R2 minus 2 into R1. Minus 2 into 1, it is 2, plus 2 is 0. Then 3 minus 4 equals to minus 1. Next 4 minus 6 equals to minus 2. Now third row operation number 3 into R minus 3 into R1. 3 minus 3 is 0. 5 minus 6 is minus 1. 7 minus 9 is minus 2. Alright. Then row 3 is equals to row 3 minus row 2. Row 3, it is 0. Then count number of non-zero rows in a row reduced echelon form. Here we do find 2 non-zero vectors here. Number of non-zero row is 2. Then the rank of the matrix A is 2 here. Then note down what do you mean by a non-zero here. The row having at least one non-zero element is called as a non-zero row here. Alright, similarly consider the next problem. It is of order 3 cross 4. Then maximum rank of this matrix is either it is 3 or less than 3. Now consider the matrix A, convert it into row reduced form. Do some operations here. Swap row 1 and 2. Next R3 is equals to R3 minus 3 into R1. So that R3 minus 3 into R1, the first element is 0. 1 minus 6 equals to minus 5. 1 minus 9 equals to minus 8. 3 minus 6 is equals to minus 3. Now R3 is equals to R3 plus 5 times R2. So that this is the answer. Then further it can be reduced. It cannot be reduced. So that this is the final row reduced echelon form. Then observe, do you find any non-zero row here? Yeah, all are non-zero rows here. We don't find any zero rows here. Then what could be the rank of this matrix? It is its order. The rank of A is 3 itself. Then find the rank of this matrix. The order is 3 cross 4. The maximum rank of this matrix is equals to or less than 3. Do some row operations. Convert this into reduced row operation, reduced row echelon form. So this is a final result here. Count the number of non-zero rows here. 1, 2, and 3. So that the order of this matrix is 3 only. The rank of this matrix A is 3. All right. So this is a method to find out a rank of a given matrix using a determinant method or row reduced echelon form. In the next video, we do see the one more theorem. And like, share, comment on the video, and don't forget to subscribe the channel. Thank you.